Welcome back, statistics fans. Here we go again. We're in the 5th section of chapter 1. Boy, time is flying when you're having a good time, isn't it? So we're going to be talking today about observational and experimental studies. Now, yesterday we talked about different types of variables and categorizing them and surveys and sampling. So let's talk about the two different studies. And our goal is that you will be able to explain the difference between experimental studies and observational studies. So let's get started. What is an observational study? This is where a researcher observes what's happening or what has happened in the past, and he tries to draw conclusions based on these observations. Now, the example that your book gave was that they noticed that the trends for motorcycle owners was that they were getting older and richer. And so I've got these little clips here because I thought they were pretty good. And wow, who's that guy? Sexy. So that's what they noticed, and they did that through observation. They looked at the owners, their incomes, their ages, and that's an example of an observational study. They did nothing to affect the outcome, and they didn't control any of the variables in the study. What's an experimental study, you ask? Well, I'll tell you. It's a study where the researcher manipulates one of the variables and tries to determine how this influences other variables. So let's say you've got a gym class that is going to do sit-ups, and they're going to count how many sit-ups they're going to do at the end of 2 weeks. You take one group, and what you wanted to see is if you gave people specific instructions on how to prepare, would they do better than people who didn't get special instructions? So your variables are the following: giving specific instructions and not giving specific instructions, and the outcome would be how many sit-ups that these people are going to do. So what they did is they told the one group, here's what I want you to do. I want you to add 2 sit-ups a day to what you're already doing. So every day do your sit-ups and do 2 extra sit-ups a day. And we'll see how it is at the end of 2 weeks. And they told the other group, hey guys and gals, do your best. And that's all they told them. They didn't give them specific instruction. So then at the end of 2 weeks, they did sit-ups for a minute and they counted them. And what they found was, surprise, surprise, the group that had the specific instructions did a lot better. They did a lot more sit-ups, like 20% more, than the group that did not receive any special instructions. So we're going to talk about this study more and how that relates to the different definitions of our terms. A quasi-experimental study. This usually happens in education. It's a study that uses intact groups rather than random sampling techniques. So in education, you could be my subjects of my experiment. That's usually what they do in education. They say, hey, does this help kids? Does this help kids? Does this increase productivity? Does this increase their test scores? We're always looking for ways to help you increase your test score. And the flipped classroom is one reason I'm doing it, is because they said that really helps the new generation. You are the new generation. Learn. And if you look down here, I have to share this little GIF that I found. Do you see this guy down here? He's like watching the computer, and there's a teacher on the computer. He's learning from the computer. Coincidence? I think not. So that's what a quasi-experimental, they do students or a special group in it. So it's quasi-experimental. The groups are not random. Okay, in an experimental study, what is the independent variable? That's the variable that's being manipulated by the researcher. It's being controlled by the researcher. It's also called the explanatory variable. In our sit-up scenario, the independent variable was the instruction that they gave the 2 different groups. That's what they had control of. So they gave the instruction to the first group, do 2 extra a day, and they didn't give any instruction to the second group. And the dependent variable is the outcome, the resultant variable or the outcome. In that sit-up scenario, the resultant variable is how many sit-ups each group did. That's the outcome. What's the treatment group? That's the one that got the special instructions that you actually do something to make a difference. The control group is the one that you don't tell anything. So you just let them be like they were. In medical research, a lot of times they will give people pills and other people placebos. The people that get the actual medication are the treatment group. The people that get the placebos, which are sugar pills that don't do anything for them, are the control group because they want to see the effect of this medicine on the different people. The Hawthorne effect. This is not the scarlet letter. No, no, no. What this says is subject could change behavior when they know they are participating in an experiment. For example, the sit-up scenario. These people might go on a diet because they know they're part of this experiment and they want to do a better job. So they change their behavior. And this is what could confound it. I'm sure you said confound it sometime. Well, maybe not, but the confounding variable. That is when you get something that influences the outcome, but they can't separate it from the independent variable. So in the case of the sit-ups, a confounding variable would be a person's own free will to go above and beyond and do more, go running, go on a diet. That could confound your study because it would mess with it, but it was something you didn't intend or control. Alrighty, let's talk about the advantages and disadvantages of these type. Experimental, that's where you're the control freak. Advantages are that you control subject selection and how your samples are grouped. And you control the independent variable. The disadvantages of experimental studies is that you could have the Hawthorne effect. It's in an unnatural setting, which may or may not apply to the natural setting. So, for example, when they do mouthwashes and they say they kill 1 million germs, well, that's in a test tube, but perhaps in your mouth, they don't kill as many germs. Confounding variable. These are things that could happen that the subjects do that could mess with your study. Observational studies. Advantage occurs in a natural setting. It can be done in situations where it would be unethical or dangerous to do the experiment. For example, they might do a study on gun owners and how many people have accidental shooting deaths in their homes. Or they might, so they compile that information, but they wouldn't want to actually do that and encourage people to shoot each other. And murder rates and assault rates and all that, they can compile those statistics or those counts and see what happened and observe. For example, the stop and frisk that has gone on in New York City has dropped the crime rate by 40%. That's almost half. So people aren't dying as much from gun-related crime and that kind of thing in New York because they started this new program. It also has a variable that cannot be manipulated by the researcher. For example, when you do that speaks for itself. The researcher has nothing to do with it. It is already occurring or it has already occurred. So it is a natural phenomena and they're just merely getting the data from that. The disadvantages of the observational studies is since the variables are uncontrolled, cause-effect is hard to establish. It can't really be shown definitely. That's like the polio ice cream thing. They compiled this data and they saw all the kids got it in the summertime, so it must be ice cream. That is an observational study that went awry because the cause effect was not accurate. It can also be expensive and time consuming to get all that stuff together. And you could get data, old data, that whoever compiled the data messed with. They didn't give you accurate data. So inaccurate data is also a disadvantage of the observational study. Okay, so hopefully you know experimental study, think control freak. Observational study, you're just observing. Okay, is it possible to reach conflicting conclusions when two studies of the same subjects are conducted? Of course. The butter saga. They're always telling you, this is good for you. No, this is bad for you. No, this is good for you. No, this is bad for you. I can go on and on and on. First, it was coffee. Coffee's bad for you. Oh, no, it's good for you. Got antioxidant. Oh, no, it's bad for you. It's got caffeine, which constricts your blood vessels. It goes on and on and on. So butter versus margarine is the one they gave. And when they first did the study in 1960, they said, oh, margarine's much better for you because it does not have saturated fat. And then they came back later and said, wait a minute. Butter's better for you because it doesn't have trans fats, and that margarine has trans fats. And then they came back later and said, no, no, no. If you do liquid margarine, it's better for you than butter because it does not have saturated fat and doesn't have trans fats either. So they go back and forth there. In the 3 studies comparing the choice between butter and margarine, why are the results seemingly contradictory? Well, it's because they changed their focus. First off, they used different types of margarine and then changed focus from saturated to trans fats. One of the things they want you to kind of get out of this first chapter, they're trying to make you better consumers and realize how people mess with these statistics that appear in the news and that appear everywhere else, so that you can make more educated choices about whether to throw out that study or say, hey, that's really something. All right, well, that's it for 1.5.